Hello everyone, this is your Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem from partial differential equation from z equal to f of y plus 2x plus x into phi of y plus 2x by eliminating the arbitrary functions f and phi. We are given a relation and we are asked to form a partial differential equation by eliminating f and phi, which are arbitrary functions. So let's see. Given relation z equal to f of y plus 2x plus x into phi of y plus 2x, right? Consider it as equation number 1. Now let's find equation involving p, so that we'll partially differentiate equation 1 with respect to x. Partially differentiating 1 with respect to x. You can just apply dou by dou x on both sides of the equation, or you can just do directly, okay? In order to avoid mistakes, I'm taking dou by dou x on both sides of the equation. Here we are partially differentiating with respect to x, so we'll treat y as constant. This gives us dou z by dou x equal to partial derivative of f of y plus 2x is f dash of y plus 2x into inner derivative dou by dou x of y plus 2x plus here you have x and phi, right? We'll apply u v whole prime formula, which is u dash v plus v dash u, right? So you'll get partial derivative of x with respect to x into phi plus x into partial derivative of phi of y plus 2x. Okay, since we know that dou z by dou x can be replaced by the notation p, we'll just replace it by p. We'll get p equal to f dash of y plus 2x into partial derivative of y with respect to x is 0 plus 2 into partial derivative of x with respect to x is 1 plus partial derivative of x with respect to x is 1 into phi plus x into partial derivative of phi of y plus 2x is phi dash of y plus 2x into inner derivative dou by dou x of y plus 2x, right? This gives us p equal to 2 into 1 2, 2 plus 0 2, 2 into f dash is 2f dash, 2 into f dash of y plus 2x plus 1 into phi is phi, that is phi of y plus 2x plus x times phi dash of y plus 2x into partial derivative of y with respect to x is 0 plus 2 times partial derivative of x with respect to x is 1. And this gives us p equal to 2 into f dash of y plus 2x plus phi of y plus 2x plus x into 2 into 1 2, 2 plus 0 2, 2 into x 2x. You'll get 2x into phi dash. Consider as sum equation number 2. Now let's partially differentiate 1 with respect to y, so that we'll get the equation involving q. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1 or do directly. If you want to solve the problem without making any mistakes, you can just apply dou by dou y on both sides of the equation. Okay, and this gives us dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. Partial derivative of f of y plus 2x is f dash of y plus 2x into inner derivative dou by dou y of y plus 2x plus here x is treated as constant, right? X into partial derivative of phi of y plus 2x is phi dash of y plus 2x into inner derivative, that is dou by dou y of y plus 2x. And also we know that dou z by dou y can be replaced by the notation q, so you'll just replace it by q. You'll get q equal to f dash of y plus 2x into partial derivative of y with respect to y is 1 plus partial derivative of 2x with respect to y is 0 plus x into phi dash of y plus 2x into partial derivative of y with respect to y is 1 plus partial derivative of 2x with respect to y is 0, and this gives us q equal to 1 plus 0 1 1 into f dash is f dash, right? You'll get f dash of y plus 2x plus 1 plus 0 is 1 1 into x phi dash is x phi dash, that is x phi dash of y plus 2x. Consider as equation number 3. So you got the equation involving q here, right? We got q equal to f dash of y plus 2x plus x into phi dash of y plus 2x, which is our equation number 3. Now let's partially differentiate 2 with respect to x so that we'll get equation involving r. We know that r is nothing but dou square z by dou x square, right? You can write this as dou by dou x of dou z by dou x. Since we know that partial derivative of z with respect to x can be replaced by the notation p, so partial derivative of p with respect to x gives r, right? So now pick the equation involving p. So this is the equation involving p. Now if we partially differentiate it with respect to x, then you'll get the equation involving r. So what I'll do is I'll just partially differentiate equation 2 with respect to x so that I'll get the equation involving r. So instead of writing p, you can write dou z by dou x here, because p is nothing but dou z by dou x, right? For our convenience, you can just write dou z by dou x, or you can write p. There is nothing wrong in it. Okay, you can take p, either p or dou z by dou x. It's up to you. Now partially differentiating 2 with respect to x. Just apply dou by dou x on both sides of 2. I'm taking dou by dou x instead of p. You can take p also. 2f dash plus phi of y plus 2x plus 2x into phi of y plus 2x, right? Fine. Here we are partially differentiating with respect to x, so we'll take y as constant. Okay, we'll just consider y as constant here, right? This gives us dou square z by dou x square equal to now you get 2 into partial derivative of f dash is f double dash of y plus 2x into inner derivative, that is dou by dou x of y plus 2x plus partial derivative of phi is phi dash of y plus 2x into inner derivative dou by dou x of y plus 2x plus 2 into, here you're having x and phi dash, right? So we are going to apply uv whole dash formula. First we will apply for x and then we'll apply for phi dash, okay? I mean derivatives we'll apply for x first, and in the next term we'll apply for phi dash, okay? So you'll get phi dash of y plus 2x into derivative of x with respect to x plus x into derivative of phi dash of y plus 2x. Clear? U dash v plus v dash u. Okay? And since we know that dou square z by dou x square equal to r, we'll just replace it by r. You'll get r equal to 2 into f double dash of y plus 2x into partial derivative of y with respect to x is 0 plus 2 into partial derivative of x with respect to x is 1 plus phi dash of y plus 2x into partial derivative of y with respect to x is 0 plus 2 into partial derivative of x with respect to x is 1 plus 2 times phi dash of y plus 2x into partial derivative of x with respect to x is 1 plus x into partial derivative of phi dash of y plus 2x is phi double dash of y plus 2x into inner derivative, that is dou by dou x of y plus 2x. This gives us r equal to 2 into 1, 2, 2 plus 0, 2. 2 into 2, 4. You'll get 4 f double dash of y plus 2x plus 2 into 1, 2. 2 into 0, 2. 2 into 5 dash is 2 5 dash of y plus 2x plus 2 into 5 dash is 2 5 dash. Okay. 1 into 5 dash is 5 dash and 2 into 5 dash is 5 dash. Okay. You'll get 2 5 dash here plus 2x into 5 double dash of y plus 2x into, it's x, okay, 2x you'll have here. It's 2x, write properly. Inner derivative, partial derivative of y with respect to x is 0 plus 2 times partial derivative of x with respect to x is 1. Clear? And this gives us r equal to 4 f double dash of y plus 2x plus 2 5 dash plus 2 5 dash gives 4 5 dash plus 2 into 1 2, 2 plus 0 2, 2 into 2x 4x is, yeah, 4x into 5 double dash of y plus 2x. Consider as equation number 4. So this equation involves r. Fine. Now we got equation involving r, right? It's r. Let's find equation involving t. T is nothing but dou square z by dou y square, right? You can write this as dou by dou y of dou z by dou y. Also we know that dou z by dou y can be replaced by the notation q. So you'll get dou q by dou. Dou q by dou y can be replaced by t. So in order to find equation involving t, we'll use the equation involving q. So this is the equation involving q, right? If we partially differentiate this equation with respect to y, we'll get the equation involving t. Okay. Now let's partially differentiate 3 with respect to y. So instead of taking q, we can take dou z by dou y, since dou z by dou y is nothing but q. Dou z by dou y and q both are same. You can take either q or dou z by dou y. I'll take dou z by dou y instead of q. Okay, now I'm going to apply dou by dou y on both sides of this equation. Instead of taking q, I'll take dou z by dou y for my convenience. Phi dash of y plus 2x. Here we are partially differentiating with respect to y, so treat x as constant. This gives us dou square z by dou y square equal to partial derivative of f dash with respect to y is f double dash of y plus 2x plus x. Since x is constant, we can write x into partial derivative of phi dash is phi double dash of y plus 2x into inner derivative dou by dou y of y plus 2x. Since we know that dou square z by dou y square can be replaced by the notation t, let's replace it by t. You'll get t equal to f double dash plus x into phi double dash into partial derivative of y with respect to y is 1 plus partial derivative of 2x with respect to y is 0. This gives us t equal to 1 plus 0, 1, 1 into x, x into phi double dash is x phi double dash. So I'll get f double dash of y plus 2x, it's double dash, okay, plus x into phi double dash of y plus 2x. Consider as equation number 5. Now observe the equations we have. So here you're having f dash x phi double dash, okay, f double dash plus x f double dash. In this equation r equal to, you have 4 f double dash plus 4 phi dash plus 4x phi double dash. See, f double dash plus x double dash can be replaced by, if you take 4 common from these two terms, you'll get 4 times f double dash plus x phi double dash, right? That term can be replaced by t. But what about phi dash of y plus 2x? You need to substitute it with some value, right, which does not involve any arbitrary functions. So for that, we'll find equation involving s also, because the equations we have is not sufficient to find the partial differential equation. So what we are going to do is we'll just find the equation involving s also. We know that s is nothing but dou square z by dou x dou y, right? We can write this as dou square z by, okay, we can write this as dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. Okay, this is nothing but dou by dou x of, since dou z by dou y is nothing but q, and this gives us dou p by dou y. Since dou z by dou x is nothing but p, so we'll get dou p by dou y. So in order to find the equation involving s, you can pick equation q. This is the equation involving q, right? So if you partially differentiate this equation with respect to x, you'll get the equation involving s. Or if you want to find equation involving s using equation involving p, just pick equation involving p and partially differentiate it with respect to y, so that you'll get equation involving s. Okay, I'll go for this. I'll pick equation involving q, that is equation number 3, to find equation involving s. Okay, partially differentiating with respect to x. Just apply dou by dou x on both sides of 3. So instead of taking q, I'll take dou z by dou y here. Equal to dou by dou x of RHS part of 3 f dash plus x phi dash. Fine. This gives us dou square z by dou x dou y equal to partial derivative of f dash with respect to x is f double dash of y plus 2x into inner derivative dou by dou x of y plus 2x, plus here you're having two functions, right, x and phi dash. So apply uv whole dash formula plus phi dash into derivative of x, that is dou by dou x of x, plus x into dou by dou x of phi dash of y plus 2x. Okay, this gives us, since dou square z by dou x dou y can be replaced by x, can be replaced by s notation, just replace it by notation s. You'll get s equal to f double dash of y plus 2x into partial derivative of y with respect to x is 0, plus 2 times partial derivative of x with respect to x is 1, plus phi dash of y plus 2x into partial derivative of x with respect to x is 1, plus x times partial derivative of phi dash of y plus 2x is phi double dash of y plus 2x into inner derivative dou by dou x of y plus 2x. This gives us s equal to 2 into 1 2, 2 plus 0 2, 2 into f double dash is 2 f double dash, 1 into phi dash is phi dash, plus x times phi double dash of y plus 2x into partial derivative of y with respect to x is 0, plus 2 times partial derivative of x with respect to x is 1. This gives us s equal to 2 into f double dash of y plus 2x plus phi dash of y plus 2x plus x, 2 into 1 2, 2 plus 0 2, 2 into x 2x into phi double dash. Right, now consider as equation number 6. Okay, now we'll use the last three equations 4, 5 and 6. Okay, so first of all take t. From equation 5 we have f double dash of y plus 2x plus x into phi double dash of y plus 2x equal to t. Right? Take equation number 6. 6 gives 2f double dash of y plus 2x plus phi dash of y plus 2x plus 2x phi double dash of y plus 2x equal to s. Right? Now take 2 common from these two equations. You will get 2 times f double dash of y plus 2x plus x into phi double dash of y plus 2x plus phi dash of y plus 2x equal to s. Right? Fine. And this can be replaced by t since f double dash plus x phi double dash is t. So we'll get 2t plus phi dash of y plus 2x equal to s. Now take this term to RHS, we'll get phi dash of y plus 2x equal to s minus 2t. Or you can say subtract 2t from both sides of the equation, then you'll get phi dash of y plus 2x equal to s minus 2t. Right? These are the two things you need to find. Now pick equation 4. We have 4. We have 4. That is r equal to 4f double dash of y plus 2x plus 4 phi dash of y plus 2x plus 4x phi double dash of y plus 2x. Right? Just take 4 common from these two terms which involves double dash, that is double derivative. We'll get 4 times f double dash of y plus 2x plus x into phi double dash of y plus 2x plus 4 into phi dash of y plus 2x. Right? You can replace it by t. We'll get 4t plus 4 into phi dash of y plus 2x can be replaced by s minus 2t, which gives us 4t plus 4s minus 8t. Right? This gives us 4s minus 8t plus 4t gives minus 4t. Right? So you got r equal to 4s minus 4t. Right? Which gives us r minus 4s plus 4t equal to 0, which is the required partial differential equation. Or we can write this as, you know that r is nothing but dou square z by dou x square minus 4 into s is nothing but dou square z by dou x dou y plus t is nothing but dou square z by dou y square equal to 0, which is the required partial differential equation. You can write in this form or in this form. There is nothing wrong in it. Okay, which is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.